Welcome to the debate. Imagine a billion-dollar industrial facility construction site.
Okay, painting a picture.
Right. You have the structural steel perfectly timed for delivery. You have, say, 500 elite welders on site, completely mobilized.
The weather window is perfect, I'm guessing?
Exactly. Ideal weather, and suddenly the entire multi-million-dollar operation it grinds to an absolute halt.
Oh, wow.
Yeah. And not because of a crane collapse or, an engineering flaw. It stops because the site ran out of legally required high-visibility vests.
Ah.
Vests and, safety gloves for the inspection team.
Spot on.
Today, we're talking about the invisible materials that quietly kill project schedules.
It really is the ultimate project management nightmare. And honestly, it happens far more often than anyone in the industry wants to admit.
Oh, absolutely.
We spend millions, right, optimizing the heavy machinery and the critical path labor. But the foundational logistics of everyday consumables, they fall through the cracks.
Exactly. So the big question we're wrestling with today is where we draw the line when we build our project schedules.
Right, the boundaries.
Yeah. Traditionally, resource leveling, the process of adjusting timelines so you don't overload your staff or equipment, it focuses purely on that direct, heavy labor.
The welders, the cranes.
Right. But there is this massive shift happening in advanced project management right now. We're looking at methodologies that integrate non-reusable material inputs into these complex management algorithms.
So tracking the consumables?
Yes, tracking the consumables alongside everything else. I'll be arguing that absolutely all non-reusable materials must be modeled to ensure an always positive stock, preventing those surprise shortages.
And that is a fascinating shift, but I'm going to be arguing that it's also a potentially dangerous one.
Oh, really?
Yeah. I mean, if you're a project manager listening to this, you're probably rolling your eyes right now. You're thinking, I have concrete pours filling and steel deliveries delayed by weeks, and you want me to track what? Printer toner?
Well, it's not just printer toner.
Disposable cups. I mean, I look at this trend of trying to model every single consumable used by both direct execution teams and indirect support staff, and I see an administrative nightmare.
It doesn't have to be a nightmare, though.
I think it is. While tracking core direct materials is obviously necessary, applying this same technical rigor to everyday administrative consumables bloats the schedule. It creates this false sense of precision,
I hear that frustration. I really do. But I look at this from the perspective of systemic vulnerability.
Systemic vulnerability. Okay, explain that.
Well, a project is fundamentally a fully integrated ecosystem. We often create this false dichotomy between direct and indirect labor.
Which are technically different budget lines.
Sure, but functionally, direct labor, your welder, your bricklayer, cannot function without indirect labor. Your quality inspector, your safety officer.
Right. The inspector has to sign off.
Exactly. Both of these groups actively consume non-reusable materials just to exist on site. If those materials aren't modeled as a strict, algorithmic system of input, output, balance, and stock, the project is flying blind.
Flying blind is a strong phrase.
But it's true. Because a brilliant schedule without the physical materials to support the workforce is, frankly, just pure fiction.
Look, I completely agree that indirect labor is vital. A welder cannot weld if the inspector isn't there to sign off on the work front.
Exactly. Nothing happens.
Right. If the actual physical location isn't released, no execution happens. But we have to draw a pragmatic line between what requires deterministic mathematical scheduling and what simply requires good site management.
Good site management isn't mathematically guaranteed, though.
But integrating complex algorithms to track subsistence items, like drinking water or toilet paper, putting that alongside critical path materials like structural concrete, feels like a complete exaggeration of control.
Okay, let's zoom out a bit. Let's look at the reality of the field, especially on remote industrial sites.
Like a mining camp.
Right, a mining camp or an offshore rig. Roles out there are incredibly fluid. An electrician might do direct work on a Tuesday, physically pulling heavy cables.
Okay.
On Wednesday, that same electrician might be doing indirect work, conducting safety inspections or commissioning tests. Because their role is fluid, the materials they use are shared.
Sure, they use the same gear.
Right. They need hydration supplies, they need PPE.
If you don't systematically track the consumption of these items based on your labor curve, your workforce literally stops.
Well,
If a remote site runs out of particulate masks, production halts just as definitively as if you ran out of concrete.
I'll give you that. The stakes change on a remote site, but let me introduce a different way to look at this. Think about how a modern video game engine works.
A video game engine?
Yeah, stick with me. If a game engine tries to render every single blade of grass behind a mountain you aren't even looking at, what happens?
It bogs down the processor.
Exactly. It consumes all the system's memory, the frame rate drops to 0, and the game crashes. That's essentially what happens to a project management team when you model paperclips and safety glasses in a master schedule.
I think that's a bit of an extreme comparison.
Is it? You are eating up your project's computational power, meaning you're planning team's time and attention. If I'm running a project, I need my scheduling software focused purely on rendering the critical path.
But the critical path requires those background items to function.
Sure, but I don't need a predictive software algorithm for hydration supplies. I need a bulk purchasing agreement, some operational buffers, and a logistics manager who actually checks the supply closet.
Checking the closet doesn't scale.
Basic minimum stock purchasing handles this background noise perfectly well without adding thousands of lines of data to a master schedule.
But you're assuming human intuition can scale at the same rate as a massive industrial project, and history shows us it simply cannot.
I'm relying on procurement buffers, not just intuition.
Even so, a remote construction site scaling from, say, 50 people during foundation work to 500 during mechanical assembly, that creates massive nonlinear spikes in consumption.
Well, obviously, consumption goes up.
Yes, but if you rely on a site manager just checking the closet with static buffers, you are begging for a supply rupture. The beauty of advanced tools like Spider Project, for instance, is that they calculate that spike for you.
By tracking every bottle of water?
By mathematically linking the consumption of subsistence and safety materials directly to the scheduled activities, the software synchronizes your supply chain with your labor curve.
I mean, in theory, that sounds great.
It automatically generates the procurement schedule, no guessing required.
But you're assuming a level of predictability in human behavior that simply doesn't exist. You're trying to model the unmodelable.
How is it unmodelable?
Well, operational supplies, say batteries for the communication radios, or temporary energy for the site trailers, they're highly variable. An inspector might drop their radio in the mud and need a new battery.
That's just an outlier, though.
Or someone leaves a high-powered light on overnight. When you try to map these micro-consumables to a rigid, deterministic schedule, you just create noise.
It's not noise, it's data.
It's noise. And this goes back to my rendering analogy. If the software is tracking everything, it alerts you to everything.
Which is what you want.
No, because the project manager ends up spending hours resolving schedule warnings over AA batteries instead of focusing on the delayed delivery of the structural steel. We call it warning blindness. When everything is a critical alert, nothing is.
Okay, I think Warren blindness is a symptom of poor software configuration, not a flaw in the philosophy of total modeling.
I don't know. It seems pretty inherent to the philosophy.
Let's shift away from human consumables for a second, because humans are unpredictable. I'll grant you that. Think about shared equipment.
Okay, equipment.
This perfectly illustrates why ignoring indirect materials is so dangerous. Let's look at a primary diesel generator on a site. That generator serves both direct and indirect needs.
Sure.
It powers the heavy execution tools for the direct labor while simultaneously powering the supervisor's technical container, the lighting, the servers.
Yeah, it runs the site.
Right, that generator consumes diesel, lubricants, oil filters. If you don't model the diesel consumption strictly based on the scheduled utilization of that generator, it stops. And when it stops, everything stops. Execution, supervision, servers, everything goes down. The diesel is a critical operational constraint, therefore you must model it with the exact same mathematical rigor as the steel.
Wait, hold on. I absolutely agree that diesel for a primary site generator is a critical path constraint. No one is arguing against tracking primary fuel.
But that's exactly what you're arguing against when you say we shouldn't model indirect supplies.
No, let's look at the logical extreme of your methodology. The philosophy you're defending also applies to the supervisor's pickup truck driving around the perimeter,
which also needs fuel.
or a quad bike used for quick field communication. Are you honestly suggesting it is necessary to model the gasoline used by a supervisor's pickup truck with the exact same algorithmic rigor as the main crawler crane lifting the building?
If the supervisor needs the truck to do their job, yes.
But the crane's operation is inextricably linked to the critical path. The supervisor's truck is not. When you model both with equal weight in the software, you dilute the risk profile of the project.
I disagree.
You are mathematically telling the system that a delay in gasoline delivery for the truck is equivalent to a delay in diesel for the crane. It's just not true.
It's not about telling the software they have equal impact on the final delivery date. It's about acknowledging their functional interdependence in real time.
Okay, paint that picture for me.
Gladly. Let's play out your scenario. You decide the supervisor's truck isn't critical, so you don't model its fuel. You rely on a basic operational buffer.
Which usually works fine.
Until there's a logistics hiccup and the local gas tank runs dry. Now, the supervisor cannot conduct their morning inspection of the rebar placement because they have no transport across a 10,000-acre site.
They could walk or carpool.
On a 10,000-acre site, no. Because the inspection doesn't happen, the work front cannot be released. Because the work front isn't released, the concrete trucks are turned away.
That's a very specific chain of events.
And guess what? That massive, critical path crawler crane you prioritized, it sits idle anyway. The project is an integrated web.
Yes, but
These energetic inputs, diesel, gasoline, motor oil, are the physical lifeblood of the equipment. If you leave the supervisor's vehicle fuel out of the schedule's parametric modeling, you are hiding a vulnerability from yourself.
But you can manage that vulnerability so much more simply. You put a larger fuel tank on site. You set a buffer threshold at 40% instead of 20%.
That ties up capital unnecessarily.
My concern here is schedule brittleness. When you integrate every single consumable into software, the schedule becomes so tightly wound, so dependent on thousands of microvariables that it just shatters at the slightest impact.
It doesn't shatter, it adjusts dynamically.
Project schedules are supposed to be strategic maps that give leaders visibility into major milestones. When you force them to act as tactical inventory ledgers, the schedule loses its agility. Any minor fluctuation, like a truck burning slightly more gas because the mud is thicker, now creates a variance in your software that someone has to manually reconcile.
You're raising a very valid point about data fatigue and manual reconciliation, but you're missing how modern parametric modeling actually handles this.
Am I? Because I've seen the bloat.
We aren't manually typing in 1 gallon of gas used. The technical goal here is treating the logistics of supplies with the exact same automated rigor as human resource leveling.
Still sounds like a lot of data entry.
We use parametric models. That means using historical data and project variables to calculate future needs dynamically. And to solve the exact problem you're talking about, the bloat, the micromanagement, advanced methodologies use what we call kits.
Okay, let's talk about these kits. Because from my perspective, the necessity of creating kits actually proves my point that tracking individual items is an overreach.
I completely disagree. Kits are a highly elegant mathematical solution to the data rendering problem you brought up earlier.
Elaborate on that.
Instead of modeling every individual pen, clipboard, and printed form, what the industry calls Class 4 control items, the software models a singular variable, a field control kit.
Okay.
Instead of modeling individual hard hats, safety glasses, and earplugs, you model a basic PPE kit. This prevents the schedule from becoming excessively fragmented.
So you're just bundling them.
Right. The software tracks the kit as a unified operational constraint. It allows us to maintain absolute control over the operational readiness of the workforce without the administrative bloat of tracking 1,000 individual line items.
Wait, I'm actually confused by how the software handles this in practice.
How so?
Let's say you have this basic PPE kit modeled in your schedule as a unified variable, right? A worker on site drops their safety glasses and they shatter.
Okay, it happens.
They don't need a whole new kit, they just need the glasses. But your software only understands kits.
Well,
So how does the system not force the site admin to either break the kit in the software, which destroys your data integrity, or issue a whole new kit in the system, which creates false consumption data? The attempt to simplify the bloat with kits seems to create a straitjacket when it meets field reality.
that is exactly where the parametric model shines. Because the kit isn't a static, rigid box of items sitting on a shelf.
It's not a physical box?
No, it's a living algorithm. The software isn't saying, hand John Smith box number 4. The software operates on consumption rates tied to labor volume.
Okay, I'm listening.
If the parametric model knows you have 50 indirect laborers doing quality control this week, it multiplies that head count by the historical attrition rate of safety glasses and the replacement rate of hard hats and the daily consumption of hydration supplies.
Ah, so it's aggregating the probabilities?
Exactly. It aggregates that data into the kit variable to generate a procurement order that maintains a positive stock of the underlying items in the warehouse.
So the admin just hands out the glasses?
Yes, the admin in the field just hands the worker new glasses. The software doesn't care about John Smith's specific glasses. It cares that the statistical probability of glasses breaking across a workforce of 500 was accounted for, budgeted, and shipped to the site before they were needed.
That is an incredibly sophisticated use of the software, I will admit.
It is. It really changes the game.
But I still come back to the return on investment for that level of computational effort. At what point does the cost of configuring, maintaining, and updating these parametric models exceed the cost of the materials themselves?
The software automates it.
Yes, but you are forcing your planning team to spend weeks up front inputting historical consumption rates, calculating attrition curves, and defining kit parameters for hundreds of minor items.
It's an upfront investment for project-long security.
And those consumption rates, even based on historical data, are ultimately educated guesses. How much printer toner does the quality assurance team use during the commissioning phase versus the foundation phase? It's guesswork masked as engineering.
But the cost of the planning team's time is a fraction of a cent compared to the financial hemorrhage of a work stoppage.
If the stoppage actually happens.
It does happen. The cost of a workfront halting because a specific safety item or a critical administrative form wasn't available is measured in thousands of dollars an hour in lost productivity.
I just don't think forms stop sites very often.
You'd be surprised. We know roughly how many liters of water a workforce needs per day based on climate and exertion. We know the lifespan of a welding consumable. When we classify these inputs properly, we acknowledge that treating these materials as secondary invisible items is a critical vulnerability. The software does the heavy lifting so the humans don't have to think about it.
I understand the appeal of a system that automates the thinking, really I do. But software is only as good as the data environment it lives in.
Which is why we need good parametric data.
Construction sites are chaotic, dynamic environments. By insisting that everything be modeled, you make the assumption that the plan will largely survive contact with reality.
The parametric model adjusts to reality.
I firmly maintain that operational continuity can be achieved without tightly coupling commodity inventory to a dynamic execution schedule. There are simpler, more resilient ways to manage background logistics. We have to draw a pragmatic line to protect our project managers from cognitive overload.
So, stepping back from the software for a moment, where does this leave us in terms of how we view the project site itself?
That's the real core of this, isn't it?
Right.
I look at this and see a mandate to view the project as a fully integrated system. The traditional boundary between direct and indirect labor is functionally fluid.
Absolutely.
Because both types of work are essential for production. The non-reusable materials they consume, from diesel for shared generators to safety kits, are critical constraints. By using advanced tools to synchronize supply with scheduled consumption, we maintain that always positive stock. We eliminate the cascading ruptures that turn a meticulously planned schedule into a useless document.
And I look at this and see a methodology that, while conceptually brilliant, risks going too far in practice.
Fair enough.
I entirely agree on the fluid nature of direct and indirect labor and the absolute necessity of operational continuity. We are completely aligned that the site is an interconnected ecosystem.
Right. We agree on the stakes.
But bloating a master schedule with every indirect consumable, even when bundled into algorithmic kits, risks creating a false sense of precision. It takes tools meant for high-level, strategic project control and forces them to manage highly tactical, variable inventory logic.
It is a delicate balance, I'll grant you that. It seems we have a strong point of convergence on the nature of the work itself, though.
Definitely.
We both clearly agree that the distinction between direct and indirect work is just a functional label. Both require dedicated, guaranteed material support to function. The quality inspector's clipboard is just as vital to releasing the work front as the welder's torch.
Absolutely. The days of treating indirect labor as a totally separate, secondary class of project management are over.
Agreed.
Where we fundamentally remain at odds is the required granularity of the modeling to support them. You advocate for mathematically tracking those variables within the master schedule to avoid any possibility of surprise, utilizing the full capability of parametric software.
And you lean toward traditional boundaries.
Right. I advocate for drawing a strict line, relying on robust operational buffers and strategic decoupling to avoid administrative overkill and schedule brittleness.
Well, the complexity of modern project environments means there is rarely a universal answer.
That's very true.
A downtown commercial high-rise where the hardware store is a block away requires a very different modeling approach than a liquid natural gas facility in the remote Arctic. Project managers must evaluate the specific scale, location, and supply chain risks of their own sites to find the right balance.
And it ultimately comes back to knowing your tools, understanding the limits of your software, and knowing the capacity of your team. You can have the most advanced parametric models in the world, but if your site admin team is overwhelmed by the data requirements, the system falls apart.
That is the human element that no algorithm can fully replace. You can meticulously plan the critical path, you can optimize the heavy machinery, and you can model the labor curves perfectly.
But you still need the right stuff in hand.
Exactly. Whether you trust a complex living algorithm to calculate the exact attrition rate of safety gloves, or you trust a seasoned logistics manager to maintain a robust buffer in the warehouse, the fundamental truth remains the same. The materials must be there when the worker reaches out their hand.
The execution simply cannot stop.
Could not have said it better myself. Thank you for joining us, and we will see you next time.